Right, hello Year 8. So today is going to be sort of split into two parts. I'm just going to quickly finish off about the structure of the Earth and earthquakes by how we use something called seismic waves. And then we're going to start to look at rocks and something called the rock cycle. Okay, so last lesson we looked at the structure of the Earth, and hopefully most of you can label the parts of the Earth. It's very straightforward, actually. You've got the crust, outermost layer, and then the thick layer is the mantle. Remember, that's kind of like a thick, solidy, liquid, sort of hot melted rock. Then the outer core, which is liquid, and the inner core, which is solid. How do we know all of that? Well, the trick of actually finding out about these rests with earthquakes. Now, we know that the Earth sits on these giant plates, and the UK is there on the Eurasian plate. And when these plates rub together, they can generate earthquakes. So these movements of energy can come to the Earth's surface, and that's what we feel as earthquakes. Okay. Now, I'd like to pause the video quickly and first draw a diagram like this with these parts labelled. So you've got plate 1 and plate 2. Okay, so two different plates. You've got something called the fault line. It's the bit between them. And when they rub together, you've got the epicenter. Actually, that's slightly mislabeled, so bear with me. I'm just going to quickly change this. Okay, welcome back. So I just had to make a slight little alteration there because there was an error. So where the earthquake actually happens, it's usually quite deep within the crust, you get the epicenter. So that's where the fault lines rub against each other, and that energy expands upwards as waves, and the point on the surface where we feel the earthquake strongest, that's called the focus, and then the fault lines obviously are the bit that run between the middle. So can you just quickly pause the video and draw that in, please? Okay, welcome back. So last lesson I asked you to draw something similar. They've used slightly different names here, so I identify them, but we called them constructive, destructive, and conservative. Okay, a convergent, two plates coming together, that'd be known as destructive. Divergent would be constructive, and transform would be conservative. Different textbooks and subjects describe them in slightly different ways, but the principle is the same, and you've already described them, so we don't really need that. Anyway, earthquakes can sometimes be small. We do occasionally get small earthquakes here in the UK, but they're not really anything to do with fault lines because we don't have any. But sometimes they can cause really big devastation. So how do we measure the strength of an earthquake? Well, we use a machine called a seismometer. Now, earthquake waves, when earthquakes happen, they send out these waves of energy, and we call these waves seismic waves. So we use a seismometer, which is a machine which plots the vibrations on a seismograph. And essentially, as the Earth shakes, what happens is the ball will swing more, and the paper sort of runs along. And as the ball swings, the bigger the waves that it records, the greater the strength of the earthquake. Obviously, this is the very, very simple one. The machines are much, much more sophisticated. They're all set up by satellite networks now, and yeah, they are much, much more sophisticated than this. But the magnitude is a measure of the energy released from an earthquake, and the Richter scale measures the magnitude, which is how much energy is released. Okay, so I think actually that sentence you do actually need. So the magnitude or the strength of an earthquake is a measure of how much energy is released, and it's measured on the Richter scale. So pause the video and do that now, please. Welcome back. So when an earthquake happens, you essentially get three types of waves. This is pretty standard amongst all earthquakes. They all sort of do the same thing. Firstly, you get primary waves. Okay, these last for about a minute, and they're longitudinal waves. Okay, they're meant ones that go back and forward. You won't have learned about those yet, but you will with the next topic. Secondary waves, they go side to side. And then finally, you get long waves, or what's sometimes called surface waves, and these are more violent and they move the crust back and forth as well as up and down. So you can see earthquakes actually get more and more intense as you go along. Now you might think earthquakes are all bad, but they can serve a really important purpose because we know that the structure of the earth is like this, but how do we know? Well, it's actually quite clever. Now, what we do is we have earthquake monitors set up all over the surface of the earth. So, when an earthquake happens, what happens is waves go through the crust, but they also go through the mantle and sometimes through the outer core and even the inner core. So, what that means is we can use earthquakes a bit like an ultrasound scans a baby in a woman's uterus. Okay, essentially these sound waves, because they're waves, they reflect, they refract, and because they're picked up at various points all over the world, we can use it to map the inside of the earth. So rather than have to dig down, we essentially use earthquake waves. It's like banging on the earth and listening for an echo and seeing what's there. But also, the banging on the earth and someone over here listening for that sound. That is essentially what it is. It's these waves that travel through the earth and they tell us what the inside of the earth is like. And so that is how we know that the outer core is liquid, because S waves can't travel through liquids. So if you look closely here, see the outer core is liquid, and these S waves, well, they get deflected by that liquid core. So we know the outer lit core must be a liquid. All right. So it's just a very clever way of working it out. So what I would like you to do is, just in your own words, maybe you can have a quick diagram like this. Explain, how do we know what the inside of the earth is like? So just one or two sentences. Okay. How do we use earthquake waves to work it out? Okay. Now maybe you could try and use some of the keywords up here. Some of these I haven't explained. You don't need to know about all of these. Okay. But pause the video and maybe a very quick diagram like this, and just two, three sentences to explain how we use earthquake waves to map the inside of the earth. Okay, welcome back. So, the sort of second half of the lesson is going to be focused on something called the rock cycle. Now, what this basically tells us is how we go from one rock type to another, okay, and back again. So all of you should be able to give examples of types of rock. Most of you explain the process by which rocks are formed, and try to construct a rock cycle to include three types of rock: weathering and erosion. Now, how do we know how certain rocks were made? We need to know certain things. So let's start with this. What are rocks made up of? Okay, I want you to write that question down in your book and then take a moment and try and write down what you already know. Okay, what are rocks made up of? Off you go, please. Okay, welcome back. So, rocks are made up of mixtures of minerals, and a mineral is a solid compound or element found in the ground. Okay, so rocks are essentially made up of minerals held together. So, things like calcium carbonate, copper sulfates, copper carbonate, iron oxide, silicon oxide. A lot of them are basically types of sand, which is silicon oxide forced together in different ways. So a rock is a mineral, a solid compound or element found in the ground. So pause the video and make sure you've got that in your book, please. Okay, welcome back again. So how many different types of rocks are there, and how are these rocks formed? Right, well, we're actually going to answer that properly next lesson. I've got a little bit of a practical for you to do, and I appreciate that you might not be able to go out and do this right away. So obviously I'm not going to ask to see any evidence of your work until Monday. So that gives you the whole weekend to find this. But What I want you to do is when you go out next, I want you to try and keep an eye open for different types of rock. Okay, so maybe if you're out and about doing your daily lockdown exercise and you find something which looks a little different on the ground, just stone, just pick it up, take it with you. And I want you to try and find between 5 and 6 very, very different stones, okay, or rocks. And I want you to look at them very, very closely and try and describe them. Now, if you have a bit of trouble doing this, you can cheat a little bit. What you can do is if you have any decorative stones in, say, your garden, or even if you go to, say, like a garden centre over the weekend and um, they have the stones out that you can decorate the thing. Maybe they're quite cheap. They're only like a few pence if you buy them individually. So you can take a few of those, but if you do find any out and about, try and find different ones. And what I want you to do is divide your page like this. Um, so say for example, you're able to find 6 rocks. What I would like you to do is, if you can, snap a picture of your rock. So I don't know. Let me just give you an idea. Okay, so welcome back. An example like this is basically what I'm after. So, say for example, you go out and you find some pebbles like this. Okay, if you can snap a picture, print it off, and stick it in your book. If you're very good at drawing, you can obviously sketch it up. Or even if you maybe can't find the pit, or you can find the picture of pretty much exactly the type of stone you found, you can print that off and put it in your book. And what I'm looking for is a simple description of what it was like. So, for example, these ones you might find at a beach. So they're very smooth because they've been weathered by the sea. Seem to be made up of grey and white minerals. You can see there's grey with white patches. Very hard. A stone like this would not shatter when struck. Okay, so say, for example, you get a hammer out your garage and give it a good whack, nothing much happens. When you look at it really, really close, like through a magnifying glass or even just close up with your eyes, you can see crystals in rocks like this. So what I'm after is descriptions. So colors, textures, densities that feel heavy. Is it hard? You can do a few basic tests on it. Okay, so all you need to do for the remainder of the lesson, if you can go and do this right now, great. Or if it has to wait until the weekend, fine. But go and find yourself half a dozen different types of stone. Take photos of them and descriptions like this. And I want you to try and, do these tests. I really want you to, put them through their paces. Check their texture. Really look closely at their color. Really look closely at how hard they are. So if you maybe get a coin and scrape the side, does it leave a mark? That's quite a good test for hardness. Okay, so little things like that, and tell me about the differences you find in these different stones. Now, going out and collecting your stones and then doing this, depending on how long it takes, probably take you about 10-15 minutes to find half a dozen different stones, and then it might take you a bit longer to actually do these tests and write them up, which is why I'm not going to look for this until Monday. But it might give you a little bit of an interesting project to do, and I'm glad to be able to set you a bit of a practical. Okay, so really it's a question of how closely can you observe and look at the different kind of stones you find. Now, as I said, there is a little bit of a cheat here. If you're really struggling to find different stones, you can just get some from some free samples, or not free, but samples from a garden centre. Don't mind you using that, as long as you do the same kinds of observations and tests. Okay, so you shouldn't really need me for this today because obviously I'm in school. So set you about your task, 5 to 6 different stone types, look at them, observe them, tell me what you find out about them. And then next lesson, what we're going to do is look at how these different types of rocks and stones actually form through something called the rock cycle. So year 8, good luck, and I will see you on Monday.